Suppose a computer program for recognizing dogs in photographs identifies 8 dogs in a picture containing 12 dogs and some cats. So it is a classification problem, and in the output category we have dog and cat. So pictures will be given. So from these pictures we need to identify whether it is a dog. Okay, so this dog corresponds to the yes and cat corresponds to the no category. So it is an example for it is a binary classification problem. So let's draw the confusion matrix initially. Here we'll take the actual value along the x-axis and the predicted value along the y-axis. Okay, so actual dog. So this is nothing but taken as positive. So we have another category known as cat. Cat will be considered as negative. So predicted dog and predicted cat. So this will be our true positive. This will be our false positive. This is our false negative. And this is our true negative. Okay. So now it is saying that it identifies 8 dogs in a picture containing 12 dogs and some cats. So total samples, we do not know what is the total samples given in our data, because it is given that it contain in a picture containing 12 dogs plus some cat. We know that we do not know what is the total number of cat. So we cannot say what is the total number of samples from the given data. So this data is incomplete. So we cannot identify what is the total samples. What is the what are the remaining data given? So of the 8 dogs identified, so 8 dogs identified in the sense 8 dogs predicted. So totally we are having 12 dogs plus some cat in the given data. So from the given data 8 dogs are identified, that is 8 dogs are predicted. Okay, so out of predicted 8 dogs predicted, 5 are actually dogs. Okay, they have predicted 8 dogs, predicted the output as 8 dogs. So out of this 8 dogs, 5 are actually dogs. 5 are actually dogs in the sense our true positive. Predicted as well as actual value are correct, right? So out of 8 dogs, 5 are predicted as dog. Also, they are actually dog. So which is nothing but our true positive. So here true positive value will be equal to 5. This will be equal to 5. What is the next information given? While the rest are cat. So what is this information? So rest are cat. So 8 minus 5 will be equal to 3. So this is nothing but our false positive. Why this 3 value has come as false positive? So it is predicted as dog, but it is actually cat. We need to compute the precision and recall of the computer program. So we got the value of true positive, we got the value of false positive. Now we need to obtain the value of false negative. So already I have told that. So true positive and false negative. So if you add this both, this corresponds to one class. This corresponds to the category dog. And if you add this both, this corresponds to the category cat. Okay, so in the given data we have totally 12 dog. 12 dog is given, right? So total value is equal to 12. So we can easily calculate false negative. False negative will be equal to 12 minus 5. Okay, so this will give the value of false negative, which is nothing but 7. So the formula for precision is nothing but true positive by true positive plus false positive. This is nothing but true positive by true positive plus false negative. So substitute the values. So this will be 5 by 5 plus 3. Here it will be 5 by 5 plus 7. And there be 10 balls. Okay, so here the total sample is given. So your total sample, total data or total sample is given. So Total sample is not required for us. Anyway, total sample is given as 10 balls. Let there be 10 balls. So out of this 10 balls, it is given as 6 balls are white and 4 balls are red. So totally 10 balls are given in a box. Okay. And let it be required to pick up the red balls from there. Okay. So here we have given total samples of 10 balls in a box, and it consists of white as well as red balls. So our task is picking up the red balls. So here we will consider picking up the red balls as the positive. Yes. Okay. Yes, or your outcome, this red will be considered as yes. And if you get white as the output, it will be considered as no. Okay. So two possibilities. Again, it is a binary classification task. So you can write actual red as the yes, actual white as the no. So white can be considered as no class and red can be considered as the yes class. Similarly, you have, so you can write this as predicted red, predicted white. So this will be your true positive, false negative, true negative. Here it is given. Suppose we pick up 7 balls. 7 balls as red balls. Okay. So this is the predicted value. You can say this is the predicted value. Okay. So we are predicting 7 as predicted thing is equal to 7. We have picked up 7 balls. Okay. So our task is picking up the red balls. So here condition is given. Suppose we pick up 7 balls as the red balls, of which 2 are actually red. So we have predicted 7 balls as red balls. Okay, so out of 7, only sorry. So your actual value as yes is nothing but 2. Out of 7, 2 is actual red. Okay, so totally you have predicted 7 values as yes. So out of 7 values, only 2 values are actual red. So which is nothing but your true positive. So true positive will be equal to positive. So false positive will be equal to 7 minus 2, which is equal to 5. Now it is you can easily find the value of false negative. So you can find false negative by subtracting. In the given data, it is given as 4 red. Total red balls are 4. So if you subtract 2 positive from this 4, you will get the value of false negative. 4 minus true positive will give the value of false negative. So this will be equal to 2. Similarly, you can find the value of true negative. Okay. So total white is equal to 6. Okay. So here false positive is equal to 5. So true negative can be written as 6 minus 5, which is equal to 1. So this will be your true negative. So if you add this both, you will get the total number of red balls, 4. If you add this both, you will get the total number of white balls, which is 6. So these are the given. So precision is nothing but true positive by true positive plus false positive, which is nothing but 2 by 7. For recall, your answer will be 1 by 2. Okay, so total sample in your given data. So total sample is equal to 80. Okay, so you are considering a database. In your database, you are having 80 records. Okay, so 80 records on a particular topic, of which 55 are relevant to a certain investigation. Okay, so here you can conclude that out of 80 sample, relevant records are 55. So the remaining records are non-relevant or irrelevant. You can write. So you can consider our classification task consists of two categories: relevant or irrelevant. Okay. So if 55 are relevant, so the remaining 80 minus 55 will be irrelevant data. Okay. So that's what you can write from this given data. So this is the total sample. Out of total sample, 55 are relevant. And uh, not relevant is equal to, if you subtract this, you will get the not relevant data, number of samples. 80 minus 35, sorry, 55, which will be equal to 35. So these are the data which we obtained from this first line. So now it is given. A search was conducted on the topic and 50 records were retrieved. Okay, so we are doing a search and 50 records were retrieved. Or you can say this is the predicted value. So you are predicting 50 records. Okay, so out of this, of the 50 records retrieved, 40 were relevant. So out of this, 40 were relevant, which is nothing but our true positive. So our true positive is nothing but 40. So directly you can write our false positive will be equal to 10. So let me draw the confusion matrix. So this is nothing but your actual relevant. This is nothing but actual not relevant. Here it is predicted relevant completed. Okay, so predicted not relevant. So true positive, false positive, false negative, and true negative. So here this value is nothing but 40. This value is equal to 10. Okay, so now we can directly obtain these values. So is predicted, sorry, relevant, you have totally 15, right? So here you have obtained 14. So 55 minus 40 will provide you the false negative, which is nothing but 15. Here total not relevant is equal to 35. So false positive is equal to 10. So 35 minus 10, which is nothing but 25 will be your true negative. Okay, so if you add this both, you will get the relevant 55. If you add this both, you will get the total number of samples in not relevant. So this is your confusion matrix. So now our question is construct the confusion matrix and calculate the precision and recall scores for the search. And so here 80 minus 55 will be equal to 25, not 35, it is 25. Okay, so here the value will be changed. Okay, so 10, 25 minus 10, which will be equal to 15. Precision, so precision will be equal to 4 by 5 and recall will be equal to 40 by 55. And it is given, consider a two class classification problem. Okay, so it is a binary classification problem of predicting whether a photograph contains a man or a woman. Okay, so identifying whether the photograph is of man or woman is the classification task. So since they have considered man initially, so we can consider if the photograph is predicted as man, man can be considered as positive and woman can be considered as negative class. Okay, so this is the first assumption we are making. Man is considered as positive, woman is considered as negative. Okay, so now they have given a sample of test 10 data. So 10 data is given and the predicted value for this 10 data is given. So from this we need to compute the confusion matrix and calculate all the other parameters. So here, so here I will write here, this is nothing but actual man, actual woman. Actually it is predicted as woman, predicted man, predicted woman. Say, or I will give you 5 minutes, you just try to find the values of true positive, false negative, and true negative. So true positive is nothing but in the given data you want to count how many predicted and actual value are given as man. So here the second one, both predicted and actual values man. Again for this fourth one, eighth one. So totally we have three samples, which is nothing but expected and predicted value as given as man. So true positive will be equal to 3. Okay, so next we need to find the false positive. So false positive is nothing but actual value is equal to expected value is equal to woman, but predicted value is equal to man. So here you have to calculate, consider. So here this fifth one is nothing but it is given as woman, but it is man, right? This is one. Okay, only one. So false positive, the value will be equal to one. So we have only one sample in which expected value is woman, but it is predicted as man. So next you have to calculate false negative. False negative is nothing but expected value is man, but predicted value is woman. Expected man. Man. So here it is man, it is predicted as woman. Again, man predicted as woman. So you have totally two samples. So false negative will be equal to 2. Now you have to find true negative. True negative in the sense actual and expected value are women. So 1, 2, 3, 4. So totally 4 samples. So now we got the values for true positive, false negative, true negative. So you got the confusion matrix. So this is done. Now calculate the accuracy, precision, recall, and specificity. So write the formulas and calculate the values. See, the question is suppose 10,000 patients get tested for flu. Okay, so here our problem statement is testing the disease flu is our problem statement. So we want to know whether our patient are sick or not or healthy. Okay, so if they get tested positive, they will be considered as sick. If they get tested negative, they will be considered as healthy. So our problem statement is finding whether a person is tested positive for flu. That is whether they are sick. So total sample is equal to 10,000 is given. Okay. So out of them, 9,000 are actual healthy and 10,000 are actual sick. So total sample is given. So your total sample is nothing but 10,000. So out of this 10,000, actual sick is equal to 1,000. So 1,000 people are actually sick out of this 10,000. So actual healthy is equal to 9,000. So this is the total sample data given. So now the predicted values are given. So for the sick people, a test was positive for 620. Okay. So for for sick people, this is the predicted value. Test was positive for 620 and negative for 380. These both are predicted value. Okay. So positive in the sense, so they are actually positive. For the sick people, the condition is given for the sick people. The meaning is they are actually sick. So here the actual 6 people, 620 are tested as positive. The meaning is actual and predicted value are positive. So true positive will be equal to 620. Okay, so next negative. So actual value, actual it is sick. Actually they are sick, but they are predicted as negative for 380. So here negative in the sense they are healthy. Okay, so positive in the sense they are sick. So you should understand that tested positive in the sense sick and tested negative in the sense healthy. So actual sick but tested negative. That is actual sick but predicted health is equal to 380. So false negative value will be equal to 380. So if you add this both, you will get the actual sick samples of actual sick, which is nothing but 1,000. Okay, so now next condition is given. For the healthy people, the same test was positive for 180. Okay, so what is the meaning? Healthy in the sense they are okay, actual healthy, but it is given as positive. Positive in the sense it is predicted as sick. So this value will be equal to 180. Again, for healthy people, negative 88020. So healthy, actually healthy, predicted healthy. Negative in the sense it is predicted healthy. That value is equal to 8820. So if you add this both the value, you will get the value as 9000. So we got the value for true positive, false negative, and true negative. Now you want to calculate the accuracy, precision, and recall.